Section 7.2 continues our discussion of the conic section. Today we're going to be looking at circles and ellipses. The way you would slice the cone to get a circle or ellipse is what you're seeing here. A parallel to the base cut would give you a circle if you're just cutting straight through the cone. If it's slightly slanted, that gives you an ellipse, which is that smashed circle. Okay? From the general form equation of ax squared plus bxy plus cx plus dx plus ey plus f equals 0, what you would be looking for is both x squared and y squared. And if a equals c, then you would have a circle, which means they've got same coefficient on those square terms. And if a does not equal c, so if there's different coefficients, then you would have an ellipse. Okay? All right, so you should have this handout. This is the standard form equation for an ellipse. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. Or you could have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. What you need to remember on this is that a is bigger than b. So it just depends which variable has the bigger denominator. If the larger one is under your x, then you're going to have a horizontal ellipse. Those are the ones that are going side to side. That's going to be squished from top and bottom. If it is under your y squared, then you have a vertical ellipse. Those are the ones that are standing up. Okay, now we're going to use all of this other information as we get through the notes. They are here for us to refer to as we go. Okay, so that's for an ellipse. Right below that, I've got the standard form for a circle. X minus h squared plus y minus k squared equals r squared. That's for the circle. Of course, your r squared, that you take the square root of that to get your radius, and your h and k would give you your center. All right? We're not going to do much with circles because they're really kind of boring, and you should know how to handle with that, okay? So let's focus on these ellipses. All right, first example, we're going to graph x plus 2 squared over 9 plus y minus 1 squared over 4 is equal to 1. And we are going to graph this by hand. So in order to graph it, there's 3 things that we need. We need the center, which is HK. We need the vertices, which we'll get into which one we're going to need on that. And we need the co-vertices. So if we can get those points, we can graph this. So first thing we need to decide is it horizontal or vertical? So just looking at our equation for our ellipse, I check the denominators. So the first denominator is 9, and the second one is 4. Wherever the larger one, that determines if it is horizontal or vertical. So 9 is bigger than 4, and that's under the x, so that means this is horizontal. Okay, so because it's horizontal, that means the vertices will be at h plus or minus a, comma k, and the co-vertices will be at h, comma, k, plus or minus b. Okay, so starting with the center, we need h and k. Well, remember that the standard form for the horizontal is x minus h squared over a squared plus y minus k squared over b squared equals 1. So h and k is what we need to find. So our h here we would have is negative 2, and our k is going to be 1. We've had some problems like this before. Just remember that you're changing the sign of what's inside those parentheses because we've got x minus h. So x minus a negative 2 is where that positive 2 came from there. So we just changed that sign. Okay, the vertices, we need h plus or minus a, comma k. There's going to be two of these. The vertices are the ends, the end points where that ellipse is changing direction. Okay, our k values don't change. They're still just going to be 1. Okay, so to get h, we have -2. A, if you'll remember, the 9 here is a squared. So the square root of 9 is 3. So we're going to subtract 3 and we're going to add 3 to our -2. That's our h plus a and h minus a. So that's a -5 and a +1. So our vertices would be at -5, 1, and 1, 1. Okay? Now the co-vertices are at h, k plus or minus b. These are the midpoints the other way, and we'll see where those are in just a moment. Okay, so h won't change. I'm going to have a -2 for each of those. K originally is 1. All right, so b. The 4 there is our b squared. So we take the square root of that, which is 2, and we're going to subtract that from our k, and we're going to add that to our k. So 1 minus 2 is a -1, and 1 plus 2 is 3. So -1 and 3. All right, so we are ready to graph this. So here's my coordinate plane. Okay, so starting with center. So the center is at -2, 1. Okay, that's our center. Our vertices, -5, 1, and 1, 1. And co-vertices, we calculated to be at -2, -1, and -2, 3. Okay, so now I'm just going to connect those dots. So there's the ellipse, okay? Now there is what we call a major axis, what goes the same direction as the ellipse. It connects your two vertices, and your minor axis connects the co-vertices. And there's what's called a focus, which we'll kind of get to that later, but those are just right inside towards the center, the same distance from your vertices. Okay, so that's our ellipse. All right, here's another one. I've got 4x squared plus 24x plus y squared minus 10y minus 3 is equal to 0. Okay, so that's in standard form. This is kind of what I was talking about at the very beginning. We can tell that this is going to be an ellipse, not just because this is the section that we're on, but we've got two square terms, the x squared and the y squared, and they have different coefficients. So we know that this is an ellipse because of that. Now, in order to get it in the standard form, which is what we have to do in order to graph it, we're going to have to complete the square. So in order to do that, we group the variables. So I'm going to put my x squared and my x together, and my y squared and my y together. And what we're going to do is add 3 to both sides. Okay? Now to complete the square, I hope you remember how to complete the square. I don't know if you do or not. We start by factoring out the GCF number out of each group. So 4x squared plus 24x, the greatest common factor there would be 4. So I've got 4x squared plus 6x and I'm going to leave a little space because we're completing the square. Okay, plus, and then my y squared minus 10y. Well, there's not a number that we can factor out of that, so we just leave it as y squared minus 10y. I'm leaving a space. And all that equals 3. Okay, so to complete the square, we start by taking half of 6, which is 3, and we square that. 3 squared is 9. Now we can't just add 9 to one side of an equation. We have to add it to both sides. So I'm going to say plus 9. But we have to remember this 4 that we pulled out. So it's 9 times 4 right there. Okay. Then the other one, I've got y squared minus 10y. So we take half of 10, which is 5, and we square it, which gives us 25. So we're also adding 25 to both sides. Okay. Anytime you complete the square, the next step is always to factor the perfect square trinomial that you've created. So that's going to factor to x plus 3 squared plus, and the y squared minus 10y plus 25 factors to y minus 5 squared. It always factors to where it's just half of that middle number. Equals, and let's add all this together, 4 times 9 times 4. 9 times 4 is 36. So 4 plus 36 plus 25 is 64. Okay. Now we're not quite in standard form, because if remember, both of the standard form equations ended in 1. They just equaled 1. So what we need to do is divide everything by 64. Okay. 4 over 64 reduces to 1 over 16. So I've got 1/16 x plus 3 squared. This next one does not reduce, so y minus 5 squared over 64 equals 1. Okay, so that is now in standard form, so we can find our center, our vertices, and our covertices. Okay, the center is still HK. So in this case, that's going to be a -3 and a 5. We just switch the signs of what's with our H and our X and our Y. This time, because the 64 is under the Y, that means that this is vertical. So our vertices will be H, comma, K plus or minus A. So -3 is our H. Our A, we're going to take the square root of this 64, which is 8. And we do 5 plus 8 and 5 minus 8. So -3 and 13. So -3, -3, and -3, 13 are our vertices. Then the covertices, because this is vertical, will be H plus or minus B, comma, K. Okay, so our K is 5. So what is our B? Well, that 16 is our B squared, which means that B is equal to 4. So we're going to say -3 plus 4 and -3 minus 4. And that negative 3, remember, is our h. That came from the center. Negative 3 plus 4 is 1. Negative 3 minus 4 is a negative 7. So our co-vertices are at negative 7, 5, and 1, 5. Okay, so negative 3. Negative 3, 5, right there. There's our center. Negative 3, 3, and negative 3, 13. Co-vertices, negative 7, 5, and 1, 5. Now we connect them. It doesn't look great because my scale is kind of messed up, but our major axis would be going vertically, minor axis horizontal, and our foci would be right inside on our major axis. Okay? All right, sometimes they give you characteristics and you have to come up with the equation. So we're not graphing these, we're just going to come up with the characteristics. Okay, so they told you that the major axis is from 5, negative 2 to negative 1, negative 2, which means these 2 points are vertices. And the minor axis is from 2, 0 to 2, negative 4. So those are your co-vertices. So first we have to decide if this is horizontal or vertical. So looking at my vertices, I see that my y values are the same, which tells me that this would be horizontal. Because if you remember, your vertices are h plus or minus a, comma k, which means for both of them, the y value is the same number. So because the y is the same on both vertices, this is horizontal. Okay, now this isn't on there anywhere, but this would be something good to know. Your length of your major axis is 2a. So what that means is we can use our distance formula, or we can just count in this case because it's just a straight horizontal line, to see the length of the major axis. See how far apart 5, negative 2, and negative 1, negative 2 are. So again, because the y values are the same, all we really need to do is see how far 5 and negative 1 are apart from each other. So I'm going to say that 2a is equal to, and I usually just start with my positive number, 5 minus a negative 1. And that's going to tell me how the distance between these 2 points. Well, 5 minus a negative is a plus, so 5 plus 1 is 6. So 2a equals 6, which means that a is equal to 3. Okay, now at the same time, we can say that the length of the minor axis is equal to 2b, which is another one that's not listed on that front, all those formulas. This would be one that would be good to know, though. All right, so we need to know how long the minor axis is. So it goes from 2, 0 to 2, negative 4. So I'm going to say 2b is equal to 0 minus a negative 4. Because there's no distance on the x's, it's just on those y's. So that's 4. So 2b equals 4, which means that b is equal to 2. Okay, so I found my a and my b. We also need to know, in order to write this equation, we need to find h and k. Because remember, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. So we've got our a and b. Now to find the h and k, we need to find the center. Well, to find the center would mean that we're finding the midpoint of either the major or the minor axis. It doesn't matter which one. Just kind of for a, I don't know, easy go-to answer, I'm going to say go with your major axis. This is why we did what we did in class on Tuesday. We're going to use the midpoint formula, which remember is x1 plus x2 over 2, y1 plus y2 over 2. So I've got 5 plus a negative 1. This is from my major axis over 2, comma, negative 2 plus negative 2 over 2. 5 plus a negative 1 is 4. 4 over 2 is 2. Negative 2 over negative 2 is negative 4. Divide that by 2 and you have a negative 2. So that right there is h and k. So finally, to write the equation, we have x minus 2 squared over, because this one is horizontal, it's over a squared, so that is a 9. 3 squared is 9. Plus, always a plus on that, y minus a negative 2 squared, so we might as well just make that a plus, over 2 squared, which is 4. That just came from our b squared, equals 1. So that's the equation. Okay? Okay, on this one we've got vertices are at 3, negative 4, and 3, 6, and the foci is at 3, 4, and 3, negative 2. So again, we have vertices this time, so that means they gave you the major axis. But this time, instead of giving us the minor axis, they've given us the foci, which, this is another one, the distance between foci is 2c. And I'll get into how we can use that. So once again, to write the equation, we need a, b, h, and k. So because we've got the major axis, we can get a. Same way we did on the previous example, 2a equals. And we need to know how long it is. Don't worry about the x's. I'm just going to worry about the y's. So I'm going to say 6 minus a negative 4. Well, that's a plus, which makes that 10. So 2a equals 10, which means that a is equal to 5. All right, so what we're going to have to do is we're going to have to use c in order to get a, or get b, because we already got a. If you'll notice on the front, again on those formulas, it says the a-b-c relationship is c squared equals a squared minus b squared. So we're going to use that, but in order to use that, we need to get c. So over here, I've got 2c is the distance between the foci. Well, again, the x's are the same, so we don't even have to worry about those. The distance between those is 0. Then I've got 4 minus a negative 2, which is 6. So 2c equals 6, which means c is equal to 3. All right. So we're going to plug that into c squared equals a squared minus b squared. So I'm going to say, let me change colors just to help us follow along here. I'm going to say 3 squared is equal to 5 squared minus b squared. So 3 squared is 9. 5 squared is 25. Subtract 25 from both sides. I've got a negative 16 equals negative b squared. Dividing by negative 1 or just changing those signs gives me 16 equals b squared. Square root both sides. And we've got that b is equal to 4. All right, so we've got a and we've got b. Now we need h and k. To get h and k, we got to get the center. And let's use the center of the major axis. So 3 plus 3 over 2. Negative 4 plus 6 over 2. So 3 plus 3 is 6. 6 divided by 2 is 3. Negative 4 plus 6 is 2. 2 over 2 is 1. So there's our h and our k. So the equation for this one would be x minus h, so x minus 3 squared plus y minus 1 squared equals 1. And we need to figure out our a and our b, which one's going to go where. All right, so looking at my vertices, I see that they have the same x values, which means this is vertical. So the larger denominator has to go with the y. So the a, which was, where is it? Oh, there it is, 5. We square that, so 5 squared is 25, goes under the y. And then the b was 4. 4 squared is 16. So there's your equation. Okay? All right, now we have this concept called eccentricity. Eccentricity is defined as the measure of how not round an ellipse is, how squished it is. If your eccentricity is 0, you've got a circle. If the eccentricity is 1, then it's smashed so much that it is a straight line. Okay, so it's going to be between 0 and 1 to be an ellipse. And the equation for it is right here. E equals c over a. So we're going to find the eccentricity. I've got x minus 4 squared over 64 plus y minus 3 squared over 36 is equal to 1. All right, so taking a look here, I know that my a is 8 because that's the square root of 64. B is 6, square root of 36 there. I need c. So remember, c squared is equal to a squared minus b squared. That's from the front of the packet. So c squared is equal to 8 squared minus 6 squared. So 64 minus 36, which is 28. So c is equal to the square root of 28. Okay, so now that we have c, we can finally get our eccentricity. E is the square root of 28 over a, which was 8. And you just put that in the calculator. You should get 0.66. So right there between 0 and 1. So that's good. Okay. The eccentricity of the orbit of Saturn is 0.47. Its orbit around the Sun has a major axis length of 38.36. Remember that right there? That's your 2a, because it's the length of the major axis. What is the length of the minor axis of the orbit? Okay, remember the length of the minor axis is 2b. So that's what we're looking for, is 2b. Okay, so 2a is 38.36, which means a is 19.18, just dividing 38.36 by 2. We're looking for 2b. We also know eccentricity is 0.47, which, remember, the formula for eccentricity is C over A. So I can say 0.47 equals C over 19.18, 19.18. So solving for C, we would multiply these. You'd use the calculator for sure. So C is equal to 9.01. Okay, we're still trying to get B. We've got A and C now. So to get B, we use that relationship again. C squared is equal to A squared minus B squared. So 9.01 squared equals 19.18 squared minus B squared. So you'd square each of those in the calculator, you subtract, and finally you would get that B is equal to 16.92. Finally, length of the minor axis is 2b. So 2 times 16.92. Again, put it in the calculator. You'd have 33.84 AU. Don't forget your units on those, okay? So the length of the minor axis would be 33.84 astronomical units. Okay? All right. Now, I've already done some examples like this, but I want to do a couple of them and leave one for you to do on your own. Okay, so we're changing from general form to standard form. We've got 9x squared plus 4y squared plus 8y minus 32 equals 0. They want that in standard form, and then you need to identify the conic. I'm going to do it a little bit different. I'm going to identify the conic first. Okay, so I see that I have both x squared and y squared, which tells me it's either a circle or an ellipse. And I've got different coefficients, and they have the same signs. We'll get into that next week, but that would mean that this would be an ellipse. Okay, so we want to make it look like what we've been doing, x minus h squared over a squared plus y minus k squared over b squared equals 1. So we're going to complete the square. All right, so remember, you start by putting the x's together. So I've got 9x squared. Oh, I only have one. Okay. And you put the y's together. So 4y squared plus 8y. And you move the constant to the other side of the equal sign. So plus 32 right there. Okay. Then you complete squares if you can. So the first one, that x, we can't complete the square on that one. It just stays like that because there's no second term. I'm going to factor out the 4 here. And I've got y squared plus 2y equals 32. Okay, to complete the square, half of 2 is 1. 1 squared is 1. So plus 1 there, and plus 1 times that 4 that we pulled out. After you complete the square, you always factor into y plus 1 squared equals 32 plus 4 is 36. Okay, we're getting to where we look like the standard form equation. Now we just need to get our 36 to be a 1. So dividing everything by 36. And then reducing each fraction. So we've got x squared over 4 plus y plus 1 squared over 9 equals 1. So there's your standard form equation, and that is an ellipse. Okay, I'm going to do B as well, and y'all are going to do C on your own. X squared plus 4x minus 4y plus 16 is equal to 0. Okay, so first we're going to identify the conic. There's only one square, so that tells me that this is a parabola. So this goes back to what we did yesterday in the other section. The standard form of a parabola is x minus h squared equals 4p y minus k. So we're going to put our x squared plus 4x on one side. And let's go ahead and move everything else to the other side. I left a little space because I know I'll be completing the square here. So I'm going to move my 4y to the other side, making it a positive 4y. And the 16, we're going to move it over as well. So that's a minus 16. All right, so we're going to complete the square here. X squared plus 4x, take half of the 4, and you get 2. And we add 4 on both sides. Okay. Anytime you complete the square, the next thing you do is factor it. So I've got x plus 2 squared equals 4y minus 12. Looking a lot like that standard form equation. We've got one more little bit to do. X plus 2 squared. Let's factor out the 4. So I've got 4y minus 3. And that is a parabola. The p in this case would just be 1. That's why there's not 1 in your equation. All right, I'm leaving this one for y'all. X squared plus y squared plus 2x minus 6y minus 6 is equal to 0. Let me kind of get you started. It's a circle because we have both x squared and y squared, and they have the same coefficients, which means you want it to look like this. X minus h squared plus y minus k squared equals r squared. So you're completing the square, you're factoring, and that's it. That'll get you finished. All right? There is an assignment on this. We can talk about it on Monday if we need to. Have a great weekend.